Okay, then I think let's gonna start and let's go into that area about module design for schematic and layout. We showed you several times, I believe, for those of you who deal with DSCR for a longer time, about reusing schematic parts. This time we expanded this by reusing schematic in conjunction with the layout design, so both parties are involved. And then also how about the obsolescence management, the impact of obsolete components and how to deal with them, how to update the module design, and then of course further on the project I'm currently working on. Okay, so what's on the agenda for today? First of all, a short introduction about how we work with module libraries inside of DSCR. Then about the DSCR design project structure, how are modules used in and reused in the project structure. Then reusing the schematic, as I said, this is pretty conventional, but then also reusing the layout module in my project design. Then how to identify that a part becomes obsolete and how can I do the replacement of that part, and then also populate this further to my project design. So I need to change with the obsolete part my schematic module, but also my layout module. And then further on, of course, as the module has changed, identifying in my project design, I call this instance design in my presentation, how to update my instance design with changes coming from the modified module at the end of the stage. So let's start with an overview about how a module library, we structure a module library. This is an example how it can be done. It's not necessarily that way, but you see, I do have a module library here, basically two main root passes, a module library, which has then any kind of structure down here. And then finally, I have my module down here, which is basically this part of schematic and this part of layout. On the right-hand side, we have the project structure, and as you can see, it's just above the modules. Yeah, I can have any structure again in here. And as a start schematic, just to speed up the presentation, not doing everything from scratch, I have a pre-configured schematic where basically everything is already drawn, apart from sheet 8, which is a blank sheet where I want to insert my module during that demonstration. So for presentations, I prepared some movies. So just showing you the module library. You see this is a module structure. Designs are already checked out again for time issues. And launching DG, we can see there is a schematic. The signals are color coded. That means there are constraints along with that in the module. Yeah, and the same applies for the layout. The layout is done, is finished, of course, as the module is done. Yeah, and the constraints with that layout are also in that PCB design. Yeah. As a second part, we collapse the module tree but expand the project tree. And you see this is my start schematic, as I said before. Let's launch this with sheet 1, where we see there is some drawing on. But if I'm opening sheet 8, this is the blank sheet where I actually want to introduce my module hierarchy symbol later on during the presentation. That is where we are coming from. This is what we start with. Okay, then let's carry on to my next slide. And then this is basically about how do I reuse the amplifier module, though the name is amplifier, yeah, in a schematic of my instance design, so of my project design structure. So basically, I reuse the amplifier module out of the module library, and just by dragging and dropping and saying I want to reuse it, place it in my instance design, and it will be placed as a definition item inside my schematic tree. Once it's in there, I check out my schematic, and then I, of course, open sheet 8, blank sheet, yeah, place the module symbol, connect the module symbol. While I place the module symbol, I can choose whether I want to keep the variant information, yes or no. I use hierarchy sheet connectors in order to connect this with my other schematic parts. As it's on sheet 8, I want to get the reference designators start with an initial value of 800 and be incremented by that, yeah, and then of course reuse the properties of the module values. So the reuse reference designators, I will show you that later on during the presentation. Once the module is registered and after being checked in, DSCR then knows we were reusing a module, and so the functionality view reuse status becomes available, and we can check whether we are in sync instance-wise with the module against the module library. Now we made a new schematic, so that means that relates in a new layout, isn't it? So we generate a new layout with the overall parts coming from that, and then also try to then later on reuse the layout of the module. So for the schematic, let's see how this works. As I said, this is the module library. We drag and drop, we reuse the module schematic part onto my instance design of my project. And what we should see is if I'm opening and expanding the definition level item, we should see SDRAM was initially there, but amplifier, this is the new module we just placed or reused inside of the SCR. Having that reused in the SCR, now we launch the schematic, and we'll see this is the start schematic. We go to sheet 8, which is a blank sheet as said before. And now we go into the hierarchy mode, go into the circuit library, and as it's in the design structure, we choose, and in here, let me stop that AVI for a minute. You see in here, you can then also select whether you want to keep just PCB variant information or copy all variant information, and then this is also inherited into my new design. So we place a hierarchical symbol. So we basically have the schematic now, but not yet connected to my design. So what we need in the next step is getting sheet connectors to the left and the right hand side. And of course also connecting and labeling those sheet connectors to the circuitry. This is what's going to be happening now. So once we got the labels, we now go with a double click into that design. So we can see on the top left, we are in the instance sheet. And you see, well, of course, we have all the old reference designators. As I said, I want to get that renumbered. I delete all the existing reference designators by that functionality. You see no reference designators any longer. I set a sheet property saying the initial value for that sheet should be 800. And after that, we simply rerun the reference allocator on all open parts, all open gates. Yeah. And we simply get new reference allocators allocated, all beginning with 800 and higher. Yeah. Now I want to show you also that that key functionality which is necessary to also reuse that component position and the routing of my layout module. there are two properties, and that's why I put this RE asterisk in the filter line. We see the real reference allocator of that reference designator of that design, but also the reuse file name and the reuse reference designator. And this is basically the correlation between my new R800 that should get the position of the previous R99 component of my module. So we've done that, so far as good. We close the design and we're gonna check this in. During that or after that check-in process, the DSCR structure will change so that the amplifier definition now becomes an amplifier instance block of my design. Once we have that, we can also see and verify now and from now on what is the reuse status of my design. Yeah, and we can see from my instance design we are in version 1, and in my module library I'm in version 1, which means I'm in sync now. The module has the same version number as my instance. Now we made a new schematic, so we are going to make and generate a new PCB. It's starting me for where should it register. The location actually doesn't matter, as you might know, because this is just for the first registration. Afterwards, it will anyhow be checked out to the structure of the project tree of the SCR. But we generate a new board, and we generate a 6-layer board. This will also be a kind of conflict because my module is only a 4-layer board. So later on, I have to deal with that. Yeah, the schematic is temporarily be checked out just for netlist generation. But now, as this is done, the board is going to be generated with a default shape, with a default board size. Again, here to speed this up, I load an IDF file where a layout contour is available and the connectors as fixed components are pre-placed to get some kind of structure. Also, I get the component group areas, and I'm arranging my amplifier module components to a dedicated location so that we can later on more nicely see that actually these components get the position of the modules in that section here. Yeah, but this is really the whole netlist of my instance design. Okay, that's it for the time being. Layout is also be generated, and we now will check in the newly created layout, and we are done for that part. On the next slide now, as we were reusing schematic beforehand, now we are going to reuse the layout module part in my instance design. It's more or less the same procedure as we did for schematic. We select the layout module from the module library, yeah, and drag and drop it to my instance board design, as you can see on the right hand side here. And what we should get is just simply displaying the amplifier modules layout. Yeah. Once this is done, we have that module available in layout, and what we're gonna do is basically placing that. When we place it, we can see the reuse component information. We can add the module into my design. We will face a conflict with the layer count, that there are unconnected layers. Once we fix that, we can use the snap functionality, drag move snap functionality, by selecting the module and referring to CN800, and then basically place the module onto the position inside my board. But that still has the old components and reference designators of the modules. What we want to achieve is placing the remember R800 onto the position of R99, and this is basically the final command, expand module design. This is where my new reference designators take the position of the module component positions. Once this is done, we check in the layout design and the module is placed so far. Again, to illustrate how this is actually working, in the module library, we pick the amplifier layout module and just reuse by drag and drop onto the instance design. And now it's registered as a module. As soon as we check out the board, we can see that basically both designs, my just newly generated board, but also my amplifier module layout, is going to be checked out to the same checkout path. At the next step, of course, we will launch design force because we need to place the module. This is still the place where we were before. These are my components from my new instance design. And now we are going into restrictions blocks and reuse the amplifier. We will see that there is an amplifier module available for us, yeah, and we can see the reuse component information. And you see here, this is basically the reference designator of the module, and this is the reference designator of my instance design, where I reuse the schematic and run the reference allocator to new reference designators. If I push add, I get the module layout in, and now we can see that actually layer 1 is mapped to layer 1, conductive layer 4 is mapped to layer 6 of my instance design, but conductive layer 3 is to 3, and there is still an unconnect layer available, and this is conductive layer 2. Though I change this and say layer 3 becomes layer 2 and layer 4 becomes layer 3 of the module. So I map the layers, and all I need to do now is, apart from better visualization for the demonstration now, turning off the sheet frame, I'm going to drag move the module to the position. And to make this more easier for me, I use the snap functionality. Additionally, I snap to the center point of the connector pin and put this on that position, and it's going to be placed. But still at that point, these are only more or less the placeholder of the component position. These are still the module reference components. With the expand functionality, I now get the components from the arrangement location onto the module positions. And as a result, we should now see that the top left components from the arrangement position disappeared and were moved to the instance board location. Okay, let's gonna check this in. We are done with the reuse of the layout part. Okay, now as a next step, we want to identify whether we have obsolete parts in the module, And guess what? Yes, of course, we do have. So the module has a parts list going along with it. Yeah. And in the parts list, I can search for a component status which is unavailable. Means the components are no longer available in my master library, and I should find an alternative for that. We will concentrate on R99 as did before, and we also will show that in the circuit tab, and we will find R99. Also in the parts list, you can see that R99 is unavailable. Yeah. And now we try to find a better choice. So we search for alternatives for R99 with kind of search criteria, and we'll find an alternative part called MCR11-22.4. We will select that part and reflect that new component to the parts list, which means the part list is changing, but still that does not mean that the schematic is updated. So we will compare the changed part list with the circuit, and of course we will find differences. Yeah? And so we will also reflect the change we reflected to the parts list now finally to the circuit. So the circuit will be updated by the parts list. Yeah, we don't have to open the circuit manually and make that change manually. Just for more changes, I will nevertheless open the schematic, see that the R99 is really changed in the part number. Yeah, but also I will add another capacitor to see more changes once we do the next part of the presentation. Again, once this is done, we check in schematic and layout design. How will this be done? So here we are in the module part. Yeah, this is the module library, and we open the parts list of the module library. On the component status, I search for unavailable, and we see finally that R99 is unavailable. Here, down here, we have the circuit tab, what I said, and we can watch the circuitry directly inside the parts list and also cross-communicate from the parts list items to that viewer and find the component where it's located. So you see this is R99 on the top left of my amplifier module. And now I'm trying to find an alternative part for that. With select parts, I get this option to specify search conditions. Again, these are pre-configured search conditions, up to your choices, up to your configuration. In my case, I search for the component status in combination with the component value and in combination with the rating for that component. Yeah, basically this one here, the value down here, yeah, and the rating down here. So this gives a list of 6 items, as you can see. Yeah, and if I double click the 6, I get the, oh, sorry, that was not what I wanted. Yeah, no, this is too far. Okay, hang on. So this is the list of components, and these are the 6 options I have. And in my case, I will go for the cheapest one, for the 35-cent component. What you should keep in mind is probably at the moment we have MCR10 22.4. We will replace this with an MCR11 22.4. That's all what you should see and keep in mind. So we choose this one. And now we make the change and we reflect this change to the parts list. And once this change is reflected to the parts list, we see now that the component now has a new cut part name, which is MCR11 22.4, as I said before. Yeah. Now, that component is available now, but we want to see how is the parts list compared against the schematic. Yeah. And now what we should find out and will find out, of course, is schematic is still having the old part number, though the parts list is the new part number, but schematic is the old part number. So, okay, so far so good. So again, we reflect that change of the parts list to the circuitry. Yeah. The system asks to check out the circuitry, which will be done. Layout, no, we don't need. And now it says, I did a change. I want to perform an automatic save, and it will get a new version, of course, yeah, in the structure. And if we rerun the compare just for confirming or confirmation, then we should see that there are no changes left anymore. So the parts list is in sync, the schematic, and all is fine so far. We check out the schematic, as I said, just to confirm what it looks like. And as I said, I also want to do another change. But you can see here now that this R99 already got the new part number MCR11224. Yeah. What I'm going to do is update the remaining properties of the selected components by reload. And what I also want to do is add another component down here just to get more changes. That's all. So I add another component called C25 demo _ demo, and I connect this to my part. This is really just for a graphics change and adding a component in that we better can see this. Also, what I'm going to do is, and this is an essential part, as I'm changing the module, I will later on also change, of course, the layout module. So I need to tell that component what is your layout module name and what is your, so the reuse file name, which is the reuse layout name, and what is the reuse reference designator, which is in this case, of course, the same, which is C25 _ demo. This is my original name. Okay. We are done with that. Now we change the layout. We check, we change schematic. We edit a component and we did a replace on R99, parts reload. Yeah. We check this in. Now, well, we changed schematic, so we need to forward annotate this change to the layout module, don't we? So we check out the layout module, we check out the circuitry, and then we can do a forward annotation inside the layout module. So we go to utility and run a forward annotation. So we see that C25 demo gets added, yeah, and we see that R99 has the changed part number MCR11224. Also, the final confirmation dialog says there's an add and a change part. The component is on the top left. All we need to do is get this into the layout and get the routing being done. I did this as best as I could and as simple as I could, just placing on the B side to make it easy for me to do the connection It's just to have a change, nothing else. So now we are at the stage where both sides are changed. We check in the layout module. We did a forward annotation and we did connect that to the layout. Schematic, we just check out for forward annotation purpose, so I don't need to check it in. I can do a cancel checkout, just if you might question why not checking in. So in the next thing is module is changed schematic wise, but also layout wise. Yeah. Now we go step by step and update the schematic. So we want to find out what is the change in the schematic side, but then also how do I get the change from the layout side into my instance board. So what we actually do is we will use the functionality diff update instance, and as a first stage, of course, I will use the feature view reuse status on the amplifier module instance of my design, and whether I'm in sync or not. Yeah, and this is exactly what we will see down here then. So this is the first thing we will do. Once this is done, we can compare the versions of the module and the instance. Yeah, they're really just the module part. Yeah, we will see differences in adding component and changing components. Yeah, can see, and this is the functionality compare circuit blocks. We can also see this graphically if we use the overlay differences in circuitry, which is this right-hand picture. Once we confirm that, we want to, of course, then update the instance reused, the module instance reused in my design. So we carry on in running update instance on the schematic, and that will be updated. And as a final result, once we've done that and checked in the design, we should see that, again, the view reuse status should show now. Before we were out of sync. At the end of this procedure, we are in sync schematic wise. This is what this movie shows. So we start and we select this one and say, what is the reuse status? View reuse status. And as I said, they are out of sync. This is my module in my instance, and this is the module in the instance design where we made the changes. Yeah. So because of that, we carry on. Okay, I showed the same for the layout, which would not be a must at the moment, but again, we should see that they are out of sync. So something for us to do here as well, which will be the next slide then. But now we carry on with schematic. We say diff update instance. This is checking out the whole item, and this is the first stage. We see that the new block module is in version 3. That was also what was view reuse status was showing. Yeah, but we in our design are using version 1. And now with that dialog, we have two functionalities. So one is compare circuit blocks, which is comparing really the modules only. And the next one would be then update instance, which is coming in a minute. Now this compare circuit block gives that result, yeah, which is an overview basically of what the tool found about differences, yeah. And you can actually see here the versions of the individual modules. Yeah, but it says I found component-wise changes, and this is exactly what we had before. R99 has changes, and C25_demo got newly added. So you see C25_demo and the property changes of the part. Before we had MCR10, now we have MCR11. We can also visualize that by using overlay differences of circuitry. That is really an overlay of both items, and we can cross-highlight into that graphics viewer and see the change for that component. As a next step, we now want to update the instance where we use the module. So this now calls diff update instance, and again we should see the change, which is basically we have basically now the instance design, yeah, where the amplifier is reused, and then we have here the two modules. And I just simply selected a few tabs on the left hand side. Also constraints, as you can see, get verified, and this is all configurable by you how you want to do this. Now we really run the update of the instance, and you see it's launching schematic and it's updating the instance, and at the end it should say that the instance is updated, the instance update is completed. If we go down here, then we see the C25 is added, yeah, and the changes are populated. If we check this in now, this is the final step, the final procedure, and we rerun again view reuse status, we should see that we are in sync. You see both of them are in version 3. So far they are in sync with each other. So schematic wise we are done. Now the second part is update the layout module with the changes we've done. The layout module is changed. If you remember, we forward annotated the C25, we placed it, we connected it. But now, first of all, again, we want to confirm what the AVI before showed already, that they are out of sync. So again, we use the view reuse status of this functionality. And then we update the instance. This is slightly different to schematic. So we simply delete the block out of that structure here, and reuse by drag and drop the new version of that. Yeah. Then, of course, the schematic has been changed, but my layout, my instance layout, does not know about any change yet. So we need to do a forward annotation of the changes because the schematic instance has been changed. C25_demo has been added. R99 has been changed with a new part. Yeah, so we need to forward annotate those changes to my layout, but then also expand the module, the new module graphics, placement position, routing information with a newly placed amplifier module. So this is what we should get at the end, basically. So what we do here now is schematic is done. So again, we confirm whether we are in sync or not, and we are out of sync. We are in the instance in version 1, in the module in version 2. So we delete the old module. And we simply reuse the newer version. Now, again, we check out both of them. And in order to be able to run a forward annotation, we also need to check out the schematic. But as I said, that's just needed for forward annotation. again, what we should and must see is exactly this one here. Yeah, this is exactly the change now, which we had before. We had the same message when we actually did update the module, didn't we? Yeah. We made a change in the module of amplifier. We did a forward annotation to the layout module of amplifier, and we got this message. Yeah. As now we updated the instance design, yeah, we also got a change, and we added C25 to the instance, and we got a change to R99, which is in my instance R800, yeah, and get this change with a new part number. So that's what we see here. So the components are on the top left. You see the confirming message, edit and change of part, but they are not yet in the layout down here. But all I need to do is now basically select with this edit functionality, yeah, update expanded board. This down here is an expanded board, yeah, and we know this is the amplifier module, and we know that it's changed. We got the necessary newly available components. The new routing is available, yeah. All we need to do is run this update expanded board on the amplifier and do this, and as a result we see that that component C25 underscore demo, if I turn on the ref desk, is added, and the routing also exists as I did in the layout. So finally we'll check this in. Again here I check this in as well. I could have also done a cancel checkout, wouldn't matter. But as a final confirmation, again, we confirm, are the modules in sync? Schematic wise, yes. Layout wise, same. Yeah. Okay, so, and this is the end of the presentation basically. So in a conclusion, what did we see? What did we do? We firstly did define modules for circuitry and layout. Yeah. We reused them, and from that point, once they are reused, we could trace their version status, yeah, whether they are in sync or not. We made a new layout also for based on the modules. Then we made some changes to the module. First change, because of the obsolete component, we found we replaced the part with a available component rather than unavailable. But I also added a component to see more changes basically. Yeah. Once I changed the component because it was obsolete, I compared or reflected that change to the parts list. The parts list in the SCR is like a circuitry or like a layout. It's really a design item. Yeah. So we reflected the change of the obsolete component into the parts list. The part list got changed, and therefore the part list was out of sync with the circuitry. So we compared the part list with the circuitry, and again reflected that change of part list into the circuit, which changed the part number of the circuit. Though that was changed, we also made or had other changes of the module. So we did a compare of the module, of the circuitry module, against the circuit instance design and updated the instance design. We forward annotated that change to layout to get the new components, to get the part reference designate, no, sorry, the part number change. And we also had made a change into the layout module. So again, we updated the module with the instance design and reflected that change as well. Okay, and that's it. That's the end of that presentation, more or less in time, I would say. So we are now open for questions. Um, at the moment, no question was coming in. Uh, are there any questions left from you? No. So far, no question I can see. Still keep waiting a little bit if somebody has another point or has an issue. Maybe we made the same session in German language 2 weeks ago. There was one question which at least I found pretty, well, quite interesting question. Customer was asking where does component status come from? Yeah, and this is coming from the higher level PLM system, which just to mention a few of them can be the Soul system, Windchill, Teamcenter, but it can also be an internet service like Silicon Expert or something like that, yeah, which does a nightly update, if you want so, on your component management module inside of the SCR, which can give the availability status, yeah. But as I said, it can also come from your higher level PLM system, which has an interconnection with the SCR, with the component management module, and you retrieve the component status information from there, but also the price information and many other things as you configure that. Yeah. So this is basically where this information is coming from. No more issues come up, then I'd like to close that presentation. I'd like to thank you for your time, uh, for looking at that presentation. I honestly hope you found it interesting, and thanks for attending, and hope seeing you soon. Then bye to everybody. Have a nice day, and hope to see you soon. Bye bye to everybody.